Hello, and this is adding and subtracting mixed fractions. Now first, we need to understand the difference between mixed and improper fractions. Mixed fractions have an integer right beside them. You see, this is the integer, and there is a fraction right beside them. Like for example, 5 and 1/2. The integer is still part of all the numbers. And the fraction is also the number itself. These two can also be represented as 5 plus 1/2. And for the mixed fraction to actually work, this number, the numerator, has to be lower than the denominator. So the numerator always has to be lower than the denominator for it to work. And if, and this is only if, the numerator is greater than the denominator, it must be turned into the integer itself. The improper fractions. The improper fractions are basically the fractions that have a higher number in the numerator than the denominator. As you can see, 9/8 is an improper fraction, since the numerator is equal to 9, but the denominator is equal to 8. So therefore, the numerator is larger than the denominator. Now we know the difference between mixed and improper fractions. How do we convert them? Well, let's first have an example. We have the integer 3 and the numerator of 1 and the denominator of 2. But we can also visualize this as 3 plus 1/2. And if you recall grade 8 mathematics, we can also know that this, the number 3, actually has a denominator of 1. Now to add the two fractions, we need the same denominator. And so we can actually multiply the denominator by 2 to turn it into, well, the same denominator of 2. But if we're going to do that to the bottom side, we must do that to the top. And this just becomes the new 6/2 plus the original 1/2. And since they're the same numerator, we can obviously see that we just have to add these two top numbers, and brings us to an answer of 7/2, which means this is actually the same as 3 and 1/2, our original equation. Okay, so why is this method important to us? Well, we need them in the first step of adding and subtracting mixed fractions. We need to turn mixed fractions into improper ones. Now this is very important, and I'll get to it later, but we just then follow our original steps to add and subtract normal fractions, which is get the same denominator. Get the same denominator, and then our final step is to add the numerators. Now let's finally use this in a real example. If we have 3/1/2 plus, well, let's say 5 1/2. How are we going to turn this into an actual improper equation? Well, we can use our steps as the same before. 3 in the denominator of 2 turns into 6/2, as we know, which is plus 1/2. I'm going to use these little brackets to separate them from the other ones. And 5/2. Well, with 5/1, 5/1 is, well, the integer 5. So we can actually turn this into by multiplying this times by 2 each on each side to create 10/2 plus the actual real fraction 1/2. And then we can simplify these by just adding the numerators inside these whole equations, where we get 7/2 plus 11/2. And now this is just simple. We already have the same denominator, so that's lucky us. And then we can just add the we can add the numerators together, which makes 18/2. Now, I don't know if I were you, but I would personally simplify the 18/2 into 9, since we learned that 18 divided by 2 is equal to 9. Now, our last example was very easy, so we're going to do a little hard one by making the denominators not equal. So we have 3/1/3 plus this is the very shocking part, 2 and 2/5. As you already can see that these two denominators are not equal. We can work that out as we go. So we got the integer of 3, and we got to put the denominator up. Then we got the fraction 1/3, and then we do the other fraction, which we get 2/1 from our integer, plus our original 2/5. Now we're trying to get the same denominator, so we're going to times this by 3 to get the same denominator as this guy, but we also got to do it for over here, which means the equation is now 9/3. I'm going to do this in a different color. 9/3 plus 1/3, and we're going to do the same thing. This denominator is 5, so we times the other one by 5, and we also do this for the top integer to make it equal, and that's 10 over wrong color, my bad. 10/5 plus our original 2/5. And now, what does that equal? Well, we can add these two together. So the first fraction becomes 10/3, and these two are going to become 12/5. We're not done yet though, because we want these guys to be equal denominators, and 3 and 5 are clearly not. So how can we fix this? Well, we can try our original method, but it's not going to work. If we times this by 5 and this by 5, this is going to be a denominator of 15, while this is going to be 5. But wait, I can hear you. We can also times this by 3. 3 times 5 and 5 times 3 are just rearranged, so these are equal. But remember, we can't forget about the top side. So we get 50/15, and our second fraction equals to 12 times 3, which is 36, and 5 times 3, which is 15. Which we can beautifully equate that into a single equation, 86 over 15. Now, remember, I'm not personally going to do this, but you have to turn it into, we have to turn it back into a mixed fraction for this to work. Many teachers are actually hating on this because, well, you don't want it to turn back into a mixed fraction. Some teachers actually like improper fractions as their answers. Some teachers don't. It matters on your teacher. But I'm going to personally teach you how to turn this into a mixed fraction. Now we're going to learn how to turn our answer in improper fraction into a mixed equation. Our original answer from the last example was 86 over 15. So how do we turn that into an mixed equation? Well, what I like to do is minus 15 from 86 over and over again. That minus 15 is, well, I'm good at math, so that would be 71. And we can list our 15 over 15 again. Remember that we're subtracting the denominator's amount, and you'll see later on why we do this. Then can we subtract 15 again? Well, yes we can. From 71, it would equal to 56. Can we do it again? Well, of course we can. We can turn that into 41. Can you subtract 15 from 41? Of course you can. It's 26. Can you do that again? Well, of course you can. It'll turn into 11. And now here's the main question. Can we subtract 11? Can we subtract 15 from 11? No. So we're going to leave 11 alone and keep our denominator. Remember, this has to be equal to this side, which is pretty shocking and you imagine, but it's how it works. But 15 over 15 is just 1 on the integer. So you can repeat this. So that's 1. 15 over 15 is 1. Repeat that. And we repeat that one last time. We got this funky 11 over 15. And the next part, we got 5 plus 11 over 15. As you know, this is willing to now turn into the equation we once had, 5, 11, 15. And boom, we just turned an improper fraction here into a mixed fraction here. So congrats. Okay, so now let's review. So first we turn mixed fractions into improper ones, all of them. Second, we make the whole equation have the same denominator. 3, we add / subtract. Then the optional step, turn the equation into mixed back again if your teacher wants you to do that. And that's it. That's the entire unit. I recommend practicing this more than you would ever imagine, really. This is a very repetitive task, if you know it, but you're going to be doing this a lot throughout the entire grade and maybe in the future. So you probably want to get the hang of it. Do your homework, and always listen to your teacher. Your teacher will guide you through this. If they have tricks that I personally don't know, and if you like those tricks, you can implement it into your tests, your homework, your general work. I don't know, but it's very important to listen to your teacher. And that's the end of the unit. I hope you have a great day, and this is FX teaching you how to add and subtract mixed fractions.